Welcome to another episode of libGDX-Graph devlog. In this episode, I'll show how to creatively use some math functions and also how to create a dissolve effect. So I start off with this shader that basically has just this color here, nothing really interesting here. And what I'd like to do with this is to be able to disappear any model that is using this shader, and just not disappear as in blink out of existence, but like creatively some pretty cool effects to do. So let me start off with I create a noise effect, noise 3D effect. I provide the object position here. I'll extract the value here for noise scale with a default value of 3. I assign it to the scale. And there is one more thing here that I can add that wasn't before, is basically a range. So I can specify here a range of the noise, the values that I want to be generated, so it's much easier, so I don't have to multiply it separately, then also remember what values does the noise generate and so on. So I'll create here a new property for noise value with the default of 1.5, and not noise value. And what I'll do here, because I want to have a range from minus 1.5 to 1.5, so I have to create a minus 1.5 by multiplying it by minus 1. So constant minus 1. And I'll multiply these two values, and then I'll create a merge these two values, so the negative into x and positive into y, and this will give me the noise range in the vector 2 here. Okay, so we have this here. Let me just group it nicely here. Noise range. Okay, so this creates my noise range. I have a result now for each point of the model, and what I can do now is I can use it for now to show you, or maybe I'll do. So what I want to do here is actually step. So basically say whenever this value is 0 or below, it's going to be 0. And everything above is going to be 1. So I'll use here a dissolve factor. So basically dissolve. And this is basically a value that will allow me to disappear from going from 0 to 1. So I'll provide a property here. This is going to be my edge at which I do 0 or 1. I'll use it for now to show you this. So the higher the number, so 0, 0, 0, 1, 2, 3, 4, 5. The more it is being consumed by the noise here. But that is not exactly what I want to do with this. So what I want to do here, instead of using this as a color, I want to use it as an alpha. So this noise generates value from minus 0.5 to minus 1.5, so the minus noise value to noise value. And I'm providing an edge at which point I cut it off so that everything above is more disappearing and everything below, so minus 0.3, it's almost all visible. Okay, so that's not exactly what I want. I want to reverse this effect. So what I'll do here is create a math arithmetic subtract, and I take a value of 1, minus this value of step. So I'll subtract 1 minus this step and use that as an alpha. And then the more I grow this value, so let's say I'll start with minus 0.5, the more is visible. It depends up to you what you want to do. If you want to, with increasing value of dissolve, disappear something. So 0.3 is almost invisible, 0.2 is whatever. Okay, but that's still not something I want to do. I want to add some kind of control. So this is kind of effect I used for disappearing the spaceship in the Game Jam demo. But I'd actually like to do something different here. Pixel color here. Let me group this. I can move this away. Okay, so this is something you can directly use in the example. So you can use it in example. So I have a code set up here. I can dissolve any kind of object. So in here we define the scale, so how big the blobs are, basically. And noise value is how spread the values are. What is going to be the range of values I will be moving from to 2. Yeah, so this is a pretty cool effect, but I wanted to add something more to it. So what I want to do is do the effect I used for the spaceship's shield raising, is that I was able to go from, basically make the object appear or disappear from one direction. So to do this, I'll use a distance from plane of kind of node here, new kind of node here, utility, distance from plane. So normally you could create this kind of node from by hand, by like specifying multiple, like I think that's like 5 different nodes to be able to calculate the distance of any point from any plane. But instead I'll have here, I can use it directly, and I'll specify that I want to have a, so the plane is here defined by point on that plane. So I'll create a constant vector 3, and the point on the plane is gonna be this one. Okay, 0, 0, 0. And normal to the plane is, I'll go with constant vector 3. Let's go with 1, 1, 0, 1, 1. This will give a nice angle to it. And as the point, I'll use the world position. So this gives me signed distance. That means that if a point is in the direction of this normal, the distance is going to be positive to the plane. And if the point is on the other side of the plane, this is going to be negative. So this gives me basically a signed distance. And instead of passing it directly here to here, I'll add these two values, both the distance and the noise. This will allow me to create a pretty cool effect here. So I'll use this instead. And as you can see here, it appears and disappears from this direction. I'll use the subtract here, because it's actually doing the opposite of I have, because my normal is pointing to 0, 1, 1, so this direction towards the upper right corner here. So I subtract these two values, 1 minus the step, and I'm going from this direction now. So let's start with 0, let's go with -1, -0, 0.2, 0.4, 5, sorry, -0.9, 0.8, 7, 6, 5. So you can see this starts appearing. When I can go to 0, it's at the midpoint basically for the object, and then when it goes to positives, it's gonna increase. Okay, so let me save this and reload the shader in the demo program here. And now I can have a program make the object appear or disappear if you set the values in the opposite direction in your program. Also, I specify the scale of the noise. So if its noise value is 0, it's going to be just directly using the distance from plane, because the value that we add here to the noise output is going to be always 0. So it's going to be only using the distance from plane, which is why we are seeing this here. But if I increase the scale of the noise, we are seeing some irregularities, and the more we have, the more irregular the edge is. And of course, the value of this noise is also changing how wide basically the impact of the noise is. So I can go all the way up or just have the impact only on the slight edge here. So because we have here this value, this add results in giving us a value between negative whatever to positives whatever, and 0 is basically the edge where we disappear stuff here because of the alpha. Therefore, we can do some other stuff with this. We can, for example, as you might have seen in the demo, it was in episode 10, I believe, when the spaceship disappears, it first creates a kind of like a burnout on the edge with like a red color. You can use this basically to mix with the color of the pixel here. I'm not going to show it here, but you can refer to the examples available for the demo. So this is something that you can do. I think it's a pretty cool effect, much nicer than the one more extra thing here. I'm using culling none because by default this is back culling. So let me save it. If I reload it, you only see the front facing part of the object. If you want to see both of them, you have to turn off culling for the shader, and then you'll be seeing both sides of the object, back facing and front facing as well. So this is basically much more fun way of make something appear or disappear on the screen than just blink it into existence or get rid of it immediately in one split second, one frame. I hope you find this useful. Please consider subscribing and liking the video. Thanks for watching. Bye.